All right, here's our last video in section 6.4. We're going to cover example number 4. We're going to add and subtract rational expressions by making sure we get a common denominator first and then adding and subtracting those rational expressions together. Let's look at example number 4a. Remember, anytime we're adding fractions, we need a common denominator. So before we can get a common denominator, let's factor all of our denominators to figure out what factors we're missing. If you look at this second fraction, his denominator looks a little bit out of order. So what you could do is you could write it in order and put the negative x first and then the positive 5. So I have a negative x plus 5. Then I can factor both of those denominators. This first one is a difference of squares. It factors into an x minus 5 and an x plus 5. It looks like this second one can be factored. Actually, I can take out a negative 1, and then I have an x minus 5. So let's get a common denominator. The first one has an x minus 5, and the second one has an x minus 5. But what is the first one missing that the second one has? Looks like a negative 1, right? So let's multiply the top and the bottom by negative 1. So now it has negative 1's negative 1, x minus 5, but it looks like the second one is missing an x plus 5. So let's multiply both the top and the bottom by an x plus 5. And now that we have common denominators, we should be able to combine these two fractions into the same fraction by just adding or subtracting the numerators together. So my first fraction looks like this. My second fraction looks like this with common denominators. I can combine them into the same common denominator where I have a negative x, and then I have a positive 3 that needs to be distributed to the x plus 5. You can write the common denominator on the bottom. Just be careful not to reduce if you can't reduce from every term, okay? All right, making sure you distribute the 3 through, I ended up in the numerator with a negative x plus 3x plus 15 over my common denominator of the negative 1 times the x minus 5 times the x plus 5. Combining my like terms in my numerator, I ended up getting a 2x plus 15 over that common denominator. And it doesn't look like there's any factoring I can do in my numerator, so it looks like that would be my final answer, already reduced. All right, let's look at B. Ooh, B looks like a good one. Has lots of different things going on, 3 different fractions that we're adding and subtracting. We still just need to get a common denominator before we can put all 3 of them together. It looks like the first denominator and the third denominator are exactly the same thing. That's cool, but the middle one's a little bit out of order. So put it in order, factor out a negative 1, and now it looks really close to the other 2. It just has an extra negative 1, doesn't it? So that means the first one needs a negative 1. Well, let me erase this. The first one needs a negative 1 on top and bottom, and this third fraction needs a negative 1 on top and bottom. Now everybody has a negative 1 and an x squared minus 4 as their common denominator. Since they have a common denominator, I can smush them together into 1, but I need to make sure that I take this negative 1 and I distribute it. The middle term has an x minus 6, and then I need to make sure that I take this negative here and the negative 1. Ooh, do you notice that? It's not only a negative because it was a minus sign between when I was subtracting, but I also put another negative there with my negative 1. Do you notice that those 2 negatives then should make a positive? So be careful with that one. That one's kind of tricky. And then making sure that you take that positive 1 and distribute it through. All right, when you do that, you should end up with a negative x, a minus 9, plus 6, minus x, plus 1, plus x. So be careful with that double negative and then the negative 1 in the first fraction that you have to distribute. Now that I have that, I should be able to combine all my like terms in my numerator. I ended up with a negative x minus 2. How about you? And then remember you have that common denominator of the negative 1 and the x squared minus 4. But let's see if we can factor and simplify this a little bit more. It looks like in my numerator, can't I factor out a negative or a negative 1? When I do that, I end up with an x plus 2. And then look at the denominator. Isn't this a difference of squares? So I can also factor that a little bit more into an x minus 2 and an x plus 2. And don't forget that there's a negative 1 in front of there also. And then look, isn't this negative 1 just being multiplied with the x plus 2? And the negative 1 in the denominator is also just a factor of? And if I have a common factor of my numerator and denominator, can I reduce both of those by a negative 1? And can't I also reduce by an x plus 2 in my numerator and denominator? So what's left in my numerator? a 1. And in my denominator, I have an x minus 2. Lots of little room for error, so you've got to be really careful and organized so that you don't make any mistake, because one little mistake, even one little minus sign, messes up everything. So you've got to be really careful. All right, why don't you go ahead and try them? Here's 2 problems I'd like you to try before we move on. We're going to continue adding and subtracting, so it's really important that you understand this section before we move on to the next 2 sections in this chapter, okay? So pause the video, try these 2 problems, and then make sure you have the same answer as I do. All right, when I look at this first one, I'm going to factor this denominator into a difference of squares, an a plus 3 and an a minus 3. The second one has an a plus 3, but it's missing that a minus 3. So I'm going to multiply the top and the bottom by that factor. So now they have the same common denominator. They both have an a plus 3 and an a minus 3. On my numerator, I have a 3a, and then I have an a that I'm going to distribute through here to my second parentheses. I have a 3a plus an a squared minus a 3a in my numerator. The 3a and the negative 3a cancel each other out. That leaves me with just an a squared in my numerator over my common denominator of an a plus 3, a minus 3. Now nothing else can be factored, nothing else can be reduced, so it looks like that's my final answer. Hopefully you got the same thing too. All right, let's look at number 2. In number 2, I'm subtracting these 2 fractions, so I need to make sure I have a common denominator. The first thing I'm going to do is factor. So I factored the denominators into an x plus 4 and x plus 5. I factored my second denominator into an x plus 3 and x plus 4. And now I'm going to look to see what factors are missing. In the first fraction, it looks like it's missing an x plus 3. So I'm going to multiply the top and the bottom by an x plus 3. In my second fraction, it looks like I'm missing, an x plus 5? So I'm going to multiply the top and the bottom by an x plus 5. I have a common denominator now. I should be able to smush them. Now my numerator has an x times an x plus 3, and it has a minus 4 times an x plus 5. So I need to make sure that I distribute this x through and this negative 4 through. Here we go. When I do that, I have an x squared plus 3x minus 4x minus 20 over that common denominator. I'm going to combine my like terms in the numerator. That gives me a new polynomial of an x squared minus x minus 20. Let's see if we can factor that one even more. It looks like that's a basic factor, and I can factor that into an x minus 5 and an x plus 4. And then look, can I reduce a common factor from the numerator and denominator of an x plus 4? All right, I can't do the x minus 5 and the x plus 5, so it looks like on my numerator I still have left a factor of an x minus 5. In my denominator, I have the x plus 3 and the x plus 5. Hopefully you got the same answer on that one too. Make sure that you're comfortable with adding and subtracting, because eventually, in the next section, we're going to do some solving. We're going to add an equal to sign into these problems, so it's going to get even more challenging or fun.